Okay, in this lesson we're going to be looking at Unit 7, Chapter 7, Exponential Functions, and we're looking at graphing exponential functions, specifically using mapping rules to graph exponential functions. So the focus is on, as I just said, sketching the graphs of exponential functions using mapping rule. Okay, let's start with the first example here. I'm just going to do two examples. One will be an example where the value of c is greater than 1, and the other will be a value of c between 0 and 1. In other words, we're going to be starting with an exponential function, and the other one will start with a decay function, or a decreasing function. So, sketch the graph of the function. Y equals negative 1/2 times 3 to the 1/5 x subtract 5. The very first thing we need to be able to do here is create our mapping rule. To create the mapping rule, you should recall what we do here is you take the reciprocal of the 1/5 to get 5. There is no horizontal translation, so simply 5x. If there's a negative right here, it goes in the mapping rule. The 1/2 doesn't change, and the negative 5 or subtract 5 doesn't change here. So we simply write negative 1/2 y subtract 5. So you take the reciprocal of the 1/5. You don't change anything here, and you don't change anything here for your mapping rule. So you get negative 1/2 y subtract 5. Once we've created the mapping rule, it should be pretty easy to create a table of values for my new function. What we do, of course, is we create a table of values for our base function. The base function is y equals 3 to the power of x. This number here has nothing to do with your mapping rule. It has nothing to do with transformations. It refers to the base function that's being translated. The function that's being translated is the function y equals 3 to the power of x. A table of values for that function is here. Negative 1 and 1/3, x is 0, y is 1, x is 1, y is 3, x is 2, y is 9, x is 3, y is 27. And here's the graph of the base function. Before I describe the transformations, let's actually create a table of values using my mapping rule for the new function that I'm about to produce. So I'll go over here on this side, create a table of values for my new function, x and y. All we need to do is simply take the values that you see here in this table of values, plug them into your mapping rule, and see what the resulting points will be. So if x is negative 1, plug it into your mapping rule. If x is negative 1, I got 5 times negative 1, which is a negative 5. If I plug in 1/3, I got negative 1/2 times 1/3, that's y is a third. That's going to give me negative 1/6, subtract 5. So I might have to do a little bit of simple math here to figure that out, of course. Negative 1/6, subtract 5, that's going to be negative 1/6, subtract 5 is 30/6, and it gives me a negative 31/6. Now, negative 31/6 is about 5 1/6, or negative 5 1/6, of course. Negative 5 1/6. Let's plug in our next point. X is 0, y is 1. If x is 0, I get 5 times 0, which of course is 0. If I plug in y is 1 into my mapping rule, so I've plugged in, right? I've plugged in 0 and 1. Plug in 0, plug in 1. If I plug in 1, I get negative 1/2 subtract 5, which of course is negative 5 1/2. Let's continue to plug in the values from my original table here, 1 and 3. Plug that into your mapping rule. 1 and 3, 5 times 1 is 5. Plug in 3, I will get negative 2/3 subtract 5. Sorry, negative 3/2 subtract 5, which is negative 5 and 3/2. Which I guess, negative 5 and, let's simplify that a little bit here. Plugging in 3, I get a negative 3/2 subtract 5. Well, there's negative 1/2 subtract 5, which is going to give me negative 6.5. Negative 6.5. And let's continue. Plugging in 2 and 9, 5 times 2 is 10. Plugging in 9 for my value of y, that's going to give me a negative 9 over 2, subtract 5. Negative 9 over 2, subtract 5. If you want, we can rewrite it like this, I guess. Negative 9 over 2, subtract 10 over 2 is negative 19 over 2, which of course is a negative 8 and 1/2. Sorry, negative 9 and 1/2. Negative 9 and 1/2. And finally, let's plug in, and by the way, we're probably not going to get a chance to plot that point anyway, but we'll plug it in anyway to see what it looks like. 3 and 27, 3 times 5 is 15. You can see my scale is not large enough for that point anyway. And plug in 27, I get a negative 27 over 2, subtract 5, which is 10 over 2, and I get a negative 37 over 2, which is going to give me a negative 18 and a half. And again, we're not going to plot that point. Now let's plot the points we can graph here, however. We have the point negative 5 and negative 5 and 1/6. X is negative 5, y is negative 5 and 1/6. Now, the first thing I should probably do when graphing this is I should sketch any asymptotes. I have a horizontal asymptote at negative 5. It's always a good idea to sketch the asymptotes on your graph. You should do that when you're producing your graph. So we have a horizontal asymptote at y equals negative 5, right here. So there's my horizontal asymptote. I know it asks for that down here, but I've just done it up above, right? It asks for it down here. So here's my horizontal asymptote. Now let's plot our points. Negative 5 and negative 5 and 1/6. About right there. I've got 0 and negative 5 and a half. X is 0, y is negative 5 and a half. That's about right there. I've got 5 and negative 6 and a half. 5 and negative 6 and a half is approximately here. And I've got 10 and negative 9 and a half. That's right there. You should be able to see the shape of my function now. The graph looks something like this. Just keep in mind that this is a horizontal asymptote. This is a little difficult for me to draw on this whiteboard, but I'll do the best I can for you. There's the shape of the graph of the function, right there. Now it does say to describe all the transformations. Let's proceed to do that. We have a reflection in the x-axis, indicated by the negative right here, reflection in the x-axis. The 1/2 here indicates a vertical stretch of 1/2. We have a horizontal stretch of 5. We do take the reciprocal of the 1/5 to get the horizontal stretch. And we have a vertical translation of negative 5. A vertical translation of negative 5. There are all the transformations that are occurring on this function. Now we also need to state the domain, the range, and any intercepts that are occurring here. The domain, if you look at the graph, all real numbers. X such that X is now those real numbers. The range, the values of y that you can find points on the graph. The range are the values of y that are less than negative 5. Any intercepts that are occurring, you can see that there are no x-intercepts. The y-intercept, you can clearly see, occurs at 0 and negative 5.5 in my table of values here. 0 and negative 5.5 is my y-intercept. There are no x-intercepts, and the equation of the horizontal asymptote is the line y equals negative 5. Of course, you could have also found the y-intercept by letting x equals 0 in this equation. And of course, if you let x equals 0, you would also get y to be equal to negative 5.5 as well. Okay, there's one example. Let's have a look at another one. use a mapping rule to sketch the graph of this function. Okay, the first thing I'm going to do is I'm going to rewrite the function so that it's solved for y. So it's going to be y equals 4 times 1/2. Now, notice the exponent is negative 3x plus 6. It is critical that we rewrite that exponent by removing a common factor of negative 3. There's got to be a set of brackets there. So if I write this as negative 3 outside of x subtract 2. Negative 3x plus 6, so I know I got it correct here. Now don't forget I got to bring this 2 to the other side and call it plus 2. Now I have it written in what we call functional form, whereby it's solved for y. That's the one that we're used to dealing with. What we're going to do now is we're going to take that function and we're going to create a mapping rule for the function. We're going to create a table of values for the base function. And we're going to use our table of values or our mapping rule to create a table of values for a new function. Let's do that. Mapping rule. XY maps to. You take the reciprocal of the 3 to get 1/3. If there's a negative here, it goes in your mapping rule. So it's negative 1/3 x plus 2. The opposite of what you see there. Negative 1/3 x plus 2, comma. For the y part of the mapping rule, I simply take the 4 and the 2 as they are. Don't change anything there at all. So I get 4y plus 2. That's how I do my mapping rule. Now that I've created the mapping rule, I can create a table of values for the base function. And from there, I should be able to get a table of values for my new function. Now the base function is the function y equals 1/2 to the power of x. That is the function that I'm translating. Let's create a table of values for that base function first. -2, -1, 0, 1, 2. If x is -2, 1/2 to the -2, 1/2 to the -2 is 4. Again, if you need me to do that, we can do it over here, just to do an example. It's 1 to the -2 over 2 to the -2. Switch them around, the sign of the exponents will change, and you get 4. In a similar way, 1/2 to the -1 is 2. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2, and 1/2 to the 2 is 1/4. So there's the table of values for my base function. Now I need to use my mapping rule to create a table of values for my new function, x, y. So here's the new function. All I simply need to do is take the table of values that I have here, these values of x and y, plug into my mapping rule, and see what the result is. So if I plug in -2, 4 into my mapping rule, x is -2, y is 4. X is -2, y is 4. Let's do that. If x is -2, I'm going to get -2 times a -1/3 is a positive 2 over 3. 2 over 3 plus 2 is 2 and 2 over 3. If I plug in 4, 4 times 4 is 16, plus 2 is 18. There's a point on my new graph. Let's continue, -1 and 2. If I plug in -1, I'm going to get a positive 1/3, plus 2 is 2 1/3. Plug in 2, 2 times 4 is 8, plus 2 is 10. Plug in the point 0, 1 next, right here, 0, 1. If I plug in 0, I get 2. If I plug in 1, I get 6. Plug in the point 1 1/2. If I plug in 1, I get 2, subtract 1/3. 2 subtract 1/3 is 1 2/3. If I plug 1/2 in for my value of y, 4 times 1/2 is 2, plus 2 is 4. And finally, let's plug into point 2 and 1/4. If x is 2, I'm going to get -2/3 plus 2, which is 1 1/3. And if I plug in 1/4 for my value of y, 4 times 1/4 is 1. 1 plus 2 is 3. There's my table of values for my new function. Let's graph the function and see what it looks like. Now before I graph the function, you should always graph any asymptotes. This function has a horizontal asymptote at y equals 2. So I'm going to graph that first. Y equals 2. Right there. There's the line y equals 2. Let me just label that for you. Now let's plot our points. 2 2/3 and 18. Now, of course, 2 2/3 and 18, I don't have an 18 on my graph, so I know it's way up there somewhere. So I guess I can do some idea here. 2 2/3 and 18. Way up here somewhere. Okay. I got 2 1/3. X is 2 1/3 and 10. Right there. I've got 2 6. I got 1 2/3 and 4. 1 2/3 and 4. I got 1 1/3 and 3. You should be able to get the general shape of the graph from the points that you see there. And remember that I do have a horizontal asymptote at the line y equals 2. So your graph's going to look something like this. And because I got that horizontal asymptote, I got to make sure that I come closer and closer to this line but never ever touch it. So there's the general shape of my graph that I'm looking for. That's why it's so important to sketch your horizontal asymptote of y equals 2. Now I'm also asked to list the transformations that occur. Well, the transformations that are occurring are, I've got a vertical stretch of 4. I have a reflection in the y-axis. I have a horizontal translation of +2. And I've got a vertical translation of +2 as well. Here's my horizontal translation of +2, my vertical translation of +2. The graph has moved up 2 units. It's also moved to the right 2 units. The original graph is a decay function. But because we reflected it in the y-axis, it becomes a growth function. It's been stretched by a factor of 4, horizontally translated 2 units to the right, and vertically translated 2 units up. So we've answered this question. Okay, key ideas again. To sketch the graph of the exponential function of this form, we simply create a mapping rule for the function. We create a table of values for the base function, y equals c to the power of x, depending if c is greater than 0 or between 0 and 1. We use a mapping rule to create a table of values for the new function, and we simply plot the points. And that will enable us to sketch the graph of the exponential function. And that ends this lesson.